Hello, algebra students. Today we're going to be learning about radicals and rational exponents. First off, a radical is an expression in the form the nth root of a. So n is what we call the index that goes above the little square root symbol, and a is the number under the radical. So n is the index. It tells us which root to take of the radical. We call that the nth root of a. It'll make more sense when we see some examples with numbers. Basically, if I have a number to the power of n and the answer is a, that means that the nth root of a is that number. So numerically, an example, 2 to the power of 3 is 8. That means that the third root of 8 is 2. All right, before we get started solving, there are a couple of important core concepts to be aware of. First off, if n is odd, so if I have the third root or the fifth root, then the problem is going to have one real solution. However, if n is even, so the square root or the fourth root, then n has two real solutions. This is because both 2 squared is 4 and negative 2 squared is 4. So the square root of 4 would have two solutions, both 2 and negative 2. And one more fun fact before we move on. To write the cube root, you can also write that as an exponent of 1/3. To write a fifth root, you can also write that as an exponent of 1/5. So we use 2 cubed as an example on the last slide. We could say 8 to the power of 1/3. So the cube root of 8 is 2. That means the exact same thing as 3 over a square root of 8. So the cube root of 8 is 2. All right, let's start solving. If n is 3 and a is negative 27, that means we're finding the third root of negative 27. We need to think what number times itself 3 times is 27. Well, I know 3 to the power of 3 is 27. So negative 3 to the power of 3 is 27. So the cube root of 27 is 3. All right, the next one we would set up as the fourth root of 16. I want you to pause the video and see if you can figure out what the fourth root of 16 is. All right, we know 2 to the power of 4 is 16. The fourth root, because 4 is an even number, is actually both positive and negative 2. So it had two solutions because negative 2 to the power of 4 is also 16. All right, let's see what happens in C. We have the fourth root of negative 16. We cannot have an even root of a negative number because negative 2 to the power of 4 we know is positive 16. There is nothing times itself that's negative or positive that would equal a negative number. So there is no fourth root of negative 16. The answer to C is no solution. And one more important thing I want you to remember before we move on. If a is negative and n is odd, then b is negative. We saw that in example A. We had a negative number under the radical and an odd root, so the solution was negative. And then if a is negative and n is even, then there is no real solution. All right, if you're feeling up for a challenge, see if you can complete A through D before I do, and then check your answers. Otherwise, here they are. The cube root of negative 8. I know negative 2 times itself 3 times is negative 8. So this is negative 2. Now this one looks a little different. We're going to find the cube root of 8 first, which I know is positive 2, and then the answer is negative. So because the negative's outside of the radical, even if that was like an even root of a negative number, it would have a solution. I would just make the answer negative. So the cube root of 8 is positive 2. Because the negative's outside, my answer is negative 2. All right, 16 to the power of 1/4 can also be written as the 4th root of 16, which is positive or negative 2. And now you guys might be wondering, how do I know it's 2? How am I supposed to know 2 to the power of 4 is 16 off the top of my head? Sometimes with these, you have to guess and check. So we know it's not going to be 1, because 1 times itself as many times as it wants is still 1. So the next number to guess and check would be 2. Most of these will be whole number answers, positive or negative. If not, we'll use a calculator. You can enter this into a calculator. You'll use the caret button that's to the top left of 7. All right, the 4th root of negative 16, I believe we had as a problem already. This has no solution because you cannot have an even root of a negative number. All right, so we saw what happens when we have a unit fraction as an exponent, meaning 1 over a number as your fraction. Now we're going to see what happens when we have a full fraction as our exponent. So you're going to want to write this down with all of our examples. If I have a to the power of m over n, n is our denominator, and that was our nth root. So we still take the nth root of a, and then it's to the power of m. So that unit fraction, 1 over n, is still our nth root. M, the numerator, would be what it multiplies by, or the power. So if I had 27 to the power of 2/3, I'm taking the cube root of 27 and then putting it to the power of 2. So the cube root of 27 is 3. 3 squared is 9. All right, like I said on that last page, I'm going to want to write down that little helpful hint. So a to the power of m over n is the nth root of a to the power of m. All right, so if I have 16 to the power of 3/4, I'm finding the 4th root of 16 to the power of 3. The 4th root of 16 is positive negative 2. To the power of 3 is positive negative 8. All right, 27 to the power of 4/3. We would take the 3rd root of 27 and then put it to the power of 4. The 3rd root of 27 is positive 3. I know it's positive because it's an odd root. 3 to the power of 4 is 81. All right, negative 64 to the power of 2/3. I'm taking the cube root of negative 64 to the power of 2. The cube root of negative 64 is negative 4. Negative 4 squared is positive 16. I know that's positive because a negative times a negative is a positive. All right, why don't you guys pause the video and see if you can do the next two on your own, and then play it to see if you got it right. All right, you're going to submit your notes for today's lesson, and then you're going to go practice the IXL skill that's on Canvas. Summary of what we learned today. We learned what the nth root is. We learned what the index of a radical is. We learned that if you have the nth root of a number, it's the same as that number to the power of 1 over n. And we learned if we have a number to a fraction exponent, you can take the nth root of that and then put it to the power of the numerator.